Okay, this is the other half of our notes. And so this question right here says to find the equation of the line tangent to x equals -1 if our original function f of x is 1 over x. And so this is the function f of x equals 1 divided by x, and we want to find the tangent line at -1. So I'm going to draw my straightest tangent line I can. I'll try my best. It's hard. Okay, so not perfect, but I can kind of move this guy a little bit. We'll try one more time. So this is why we learn how to use algebra for these problems, because drawing tangent lines are pretty difficult. So here's my tangent line. I'm trying to find the equation of that line. And so I, again, am going to use my point slope form equation. And so the first thing I need is my slope, but we were told here that f prime of -1 is -1, so that means that's my slope, because the slope of the tangent line is the derivative at that point. And then the other thing is I need a point on the line. So right here you can see that it is -1, -1. But again, your graph, when it got printed out, might not be as clear, or maybe sometimes you wouldn't be given the graph. The way that you would figure that out is that you would just plug in -1 to your original function. So you do -1 over 1 over -1, and that equals -1. So that also gives me the point 1, -1. So now that I have my two pieces of information, I'll just do y minus -1 equals -1 times x minus -1. And that equals, I can like subtract a negative, it's just adding. So I'll get y plus 1 equals -1 times x plus 1. And that is the equation of this line right here. I'm going to pause for a second. Okay, I want you guys to try the next one on your own. So pause this, but I'm going to just work it out. I'm not going to say anything, but I'm just going to work it out. So if you feel like you can't do it by yourself, then just follow along here. This one also is like a little bit more obvious what the equation is just by graphing the tangent line, but that's okay. So that is that one right there. And again, it's a little bit more obvious because as soon as I graph that, you can tell that that's just a horizontal line at 0. So that one is y equals 0. If you need more time with that, just pause that, but I'm going to go on. So this problem, let's write down what it was, says find the equation of the line tangent to x equals 3 when f of x equals -2x squared. So we don't have the graph here, so that makes this harder. And also we weren't told the derivative of this. And so this one's going to be kind of more of a pain, because if we want to find the slope of our equation, we're going to have to if we want to find the slope of our equation, we're going to have to find the derivative. And so I'm going to go ahead and start doing my derivative. I'm going to use the second equation for derivative because, I don't know, I just find it easier. And I'm actually not going to just find my derivative. I'm specifically concerned about what my derivative is at 3. And so I'm going to do f prime of 3. So I'll do the limit as x approaches 3 of f of x minus f of 3 all over x minus 3. So I'm using that second definition. And I will get the limit as x approaches 3 of -2x squared minus -2 3 squared all over x minus 3. So I just plugged in x to my function. This was my function, and then I plugged in 3 to my function, and I am subtracting those two things. Then I will go ahead and kind of clean it up. So minusing 3 squared is 9. -2 times 9 is -18. So I'll have x minus 3 down here still, so that doesn't change at all. Then I will have the limit as x approaches 3 of -2x squared plus 18 all over x minus 3. If I were to plug 3 in right now, I'd have indeterminate form, but because the top is a quadratic, I am going to factor out the greatest common factor, which is -2 in this case. So that makes this -2 times the quantity x squared minus 9. And I don't know if this stands out to you guys, but x squared is perfect square, and so is 9. And so I'm going to keep going, but I'm going to factor using the perfect square strategy. So I'll do -2 times x minus 3 times x plus 3 all over x minus 3. And that is beautiful and wonderful because my x minus 3's will now cancel out. And then I can go ahead and plug in 3, and that will give me -12. And so my derivative at 3 is thus 12, and that's also the slope of my tangent line. So we don't like seeing problems like this because they're just so much more work, and we still have one more thing to do. But we have found the first thing we needed to write our equation, which was the slope. Pause this if you need more time. The second piece of information we need to know is the point, and like where it hits. So we know that it's going to hit our original function at 3. And so the original function shares this point, and so does the tangent line. This shares the same point. So I'm just going to plug in 3 into our original function to see what the y value that comes out is. So I'll do -2 times 3 squared, and that equals -2 times 9, which is -18. So our x value is 3 here, and then our y value is -18. So there's our point, and then there's our slope. And so now I can put everything in the equation. So I'll do y minus -18 equals 12 times x minus 3, and that gives me y equals 18, which equals 12 times x minus 3. And that is the equation for our tangent line. We have one more. Feel free to try it on your own, but this one is kind of finding the derivative for this one is a little bit more tricky, and so I'm going to keep explaining it out loud, but if you want to try it on your own and then come back and watch this video, that would be great too. So we are going to use, and I'm just going to stick with the second derivative equation today. I'm just feeling it. And so I'm going to find the derivative at -2 because that will give us the slope of the tangent at -2. So I'll do the limit as x approaches -2 of f of x minus f of -2 all over x minus -2, which would just be x plus 2. So x minus -2 is just x plus 2. But I'll write this out in 2 steps just in case somebody's not listening to this video. So I'll do that in the next step. Okay, so then the limit as x approaches -2, well, f of x is just 2 over x, and that will be subtracted by 2 over -2. So I'm just plugging in -2 for x, and then my bottom I'm going to write this time as x plus 2, because minusing a negative is plus 2. I'm going to clean up my numerator a little bit, so I'll have the limit as x approaches -2 of 2x minus 2 divided by -2 is -1. Negative times a negative is positive, so this is what I'll have on top. If I plug in -2, I would have indeterminate form. And so this is a strategy that might be less familiar with us, but I have a fraction on top, and I don't like the fact that I have a fraction on top. So if I want to get rid of the fraction on top, what I will do is I will multiply the top and the bottom of this, the larger fraction, by x, because by the denominator. So like I'm going to multiply it by x because the denominator of this fraction on the numerator has a denominator of x. So I know that those will cancel out. So I'm going to multiply the top by x and the bottom by x. I have to do it by both because that just means it's like multiplying by 1. And so when I do that, I'm going to write it like this, but then I'm going to distribute after. And so if I distribute that x into this, I would get 2x divided by x, which just equals 2. And then x times x is 1. And then on the bottom, I would have x times x plus 2. So I just distributed, and that's what I got. Then these two x's cancel out, so I'll have the limit as x approaches -2 of 1 over -2, or 1 over x. And then when I plug in my limit, I will get 1 over -2. And so that is my limit at -2, or sorry, that's my derivative at -2, and that's therefore the slope of this tangent line. So I'm going to keep going, but pause and try to look over what I did. And let me know if you have any questions. You can just email me. And make it smaller. The last thing we need to do, the last thing we need to do is find the point that the tangent line and the original function share, which is the x value is -2. So I'll just do f of -2, and that equals 2 over -2, which equals -1. And so the point that those two share is -2, -1. So that is a point on the tangent line. So when I put this in my equation, I'll do 5 minus -1 equals -1/2 times x minus -2. And if I clean that up, I'll have y plus 1 equals 1/2 times x plus 2. And that is your answer. Once we figure out the quicker technique, it's called, the big one is called the power rule. Once we find the quicker technique to do derivatives, these problems will not be this complicated. But right now we're still using the definition of the derivative. We haven't learned the shortcut yet. So that is it. Let me know if you have any questions. We'll do a warm-up problem like this on Monday, but then we're going to kind of move on. So make sure you watch this video. See you guys on Monday.